vehicle site. I was actually playing around with it today, and I kind of added to it. So I've got, believe it or not, in here, and I did this for a reason, kind of to show you as well how to separate things out into packages and stuff. I've got like 3 programs in here, all in one project, and they have 3 different Notepad examples. So if I open this up, the first one here is the one that's called JavaPad. If you go do a Google search, you'll find a ton of JavaPads. There's different versions of it. It's somebody's open source example. In fact, there's a bunch of tutorials on it as well. This particular one is kind of generic. It's just a stripped out JavaPad that came with a Dialog and Dialog text actually. So if you get the Dialog and Dialog text, you already have this example. And in here somewhere there's credit for it as well. So I have to make sure it's in there before I upload it as well. But long story short, what we're looking at, let me zoom in here so you can actually kind of see the code, which is the interesting part. Actually, before I do that, let me show you what it looks like so you can see what it is that we're talking about. JavaPad doesn't use a menu, if I remember this correctly. It has buttons. When we run JavaPad, I'm going to close the stuff in the background so you can sort of see what it is I'm talking about. I click on JavaPad. I get the menu up here because this is a Mac operating system that I'm running on. Your Windows system is not going to have a menu up here. This isn't going to show, so don't be concerned if this you don't get the same look and feel. You're going to have a window that has the opening, closing, minimize, and maximizing. This is a flow layout. So if you notice, as I made the window bigger, and this is a text box in the window here, and I can type in the text box. This is a text box. There we go. BOX. We've got the menu items now. It kind of scrolled funny because I made the window bigger. So I'm going to make the window smaller again so I can get the kind of the menu to show correctly. And here's the other interesting thing is you also see I'm wrapping the this is gone now. There's a this back here, but I can't see it anymore because I wrapped it too much. So I'm going to make it bigger. There we go. Now I see everything on the window. Again, and it's because of the layout that I'm using, and we'll see that in a few minutes. So if I go new, if I click on the new, it's actually going to give me a warning here. Do you wish to save? No, I don't want you to say what's here. If I go open, this is the file chooser, the way that it looks on a Mac system. On a Windows system, it's going to look like your file open. And so this is the functionality. So for example, I'm going to click on example number 2.m because I know it's a text file. And I'm going to select open. You'll have this stuff given to you by default. It's everything and everything you could ever, possibly want in terms of opening a file. The functionality of clicking on, double-clicking on stuff, don't worry about that. Leave it alone. Just make the file chooser. That's what I'm saying. So if I pressed open on that, and now you see it opened up the file. And this is the basic functionality for the file open close. So we've got the save as dialog, again a file chooser over again, the save, oops, it's been saved, the new, doesn't do very much. So, and the menu is in the form of buttons that show up on the bottom of the screen. So let me show you now the source code that goes with that, so you can sort of see how that gets put together. And the lecture is kind of twofold. I'm trying to show you different ways of designing the same application without, and you'll see it's just a matter of placing different GUIs. The components themselves are identical, and the technique is identical. So let me make this, close this down here, make this a little bit bigger. So you see the imports, just like the last lecture that we looked at, swing, AWT event, because we have button click events that are occurring on the buttons. If you have a menu, you're not going to necessarily have the same type of events. We'll see that. So we have a public class JavaPad, what extends JFrame, implements action listener. So this is our JFrame where all of the components are going to be placed. And that's that window that shows up. In a Windows, believe it or not, in Windows they actually call it a window. So JFrame is a window. It's a frame. Somebody would call me on that terminology eventually. But here it is called file chooser. Yeah, that's what I thought. So the PowerPoint, the Word file that has the assignment description in it used to be called file choose in the old days and that's a very old assignment that's been recycled over the years. The current terminology calls it file chooser, so that's what I'm referring to. I should edit that. So file chooser FC is going to be equal to a new file chooser. We should know that already. So we're taking this object, and the object here is going to be a file chooser is in the swing component, actually. That's the dialog box. That's the window that comes up. That gives us the ability to choose files. So now we have a text area, JText area. Well, that's where we're typing in the text, and the data is going to be equal to the JText area. And this is the 39 by 85 is the default size that showed up. We can make that size bigger by dragging, as you saw a few minutes ago. It's not fixed. We can make it fixed. We can add scroll bars, which we didn't do here either. We can add, all sorts of different effects to that window. Now we have 1, 2, 3, 4, 5 buttons that you saw at the bottom of the screen. These were the buttons that were called J buttons. And we have the new file, save as, open. And here's the titles that we put on the buttons. And then we have the string current file, because we want to keep track of the current file that we have opened. So it's going to be equal to untitled to begin with. So that when we open a file, we can take the title of the file from the file chooser. And it's a method that says, you pick the chosen file and give me the title, and so we can keep track of it. So when we save it, we can use the same title again. So for the JPad application here, we're going to run, because we are extending JFrame, one of the two constructors that we have is, one of them is going to take on just the name. So we're calling it JPad 1.0. So this is the constructor super. So our constructor, this is the first constructor, by the way. In fact, it's the only constructor that's put into this program. And it's kind of sloppy because main is in here as well. But our constructor is calling the superclass constructor, which extends JFrame, which has one that takes on the title. So we're sending it with the title. And this is the interesting part. So the set a mnemonic. In the old days, before we had Windows, well, actually, Windows just came out. But before we had Windows, we had DOS applications that look like Windows, but there was no mouse. Imagine life without a mouse. We used the keyboard, usually the function keys, the shift keys. Sometimes you just pressed in fact, WordPerfect was like this, and the first version of Microsoft Word were sort of like this. That's what this stuff is. So the N, the S, and the O, we can actually press Control on a Mac computer. We would press Control something, Control N, Control S, and we can use the keyboard instead of the mouse to operate the program. And the interesting thing is it used to underline. Let me see if it does actually. I didn't actually. I'm going to run it real quick because I'm curious about something. No underline, but N, so Control N. Oh, let me back up a little bit. Or is it Function N? Let's see, S was one of them. S. So maybe it's Function S. No. Ah, there it goes. I had to press Option S on my keyboard to get that. And then it's the Option key with, oh, it is underlined now. So when I press the, okay, so let me zoom in so you can see what I'm looking at. Oops. Well, I can't zoom in now because let's see, let's do it this way. Here we go. When I press the Option key on my keyboard, you see this N, S, and the O. I'm clicking it now so you can kind of see. In the old days, it used to always be underlined. It might actually be underlined on your Windows system. If you're running with a Mac, it's the options. It's the Control key on a Windows computer. On a 52 key keyboard, I think, in the old days. I believe it's if you don't see that, press the alternate key. It's going to be Control Alternate, one of those two key combinations, or one of the two keys. But this one on a Mac, it's Option. Actually, above Option, it says Alt on it, so it's probably the Alt key on your keyboard. So, but long story short, oh, it didn't even warn me when I closed that. That's what this stuff's all about. Setting a mnemonic. So the mnemonic is that, and basically it makes it so you can operate those buttons as new, save, and open. You can operate them with this mnemonic, which is a method to run on the button class and say, hey, run it this way. Okay, so setting the bounds is essentially setting the bounds of the screen, essentially. Setting the default a close operation, it's a close on exit. So if we close, setting on the JFrame, it's going to close if we click on the little red, I think it's an X on a Windows machine, or it's a little red circle on the, we can actually make it so it doesn't close. In fact, in this particular application, we should have had it call a method that says, hey, do you want to save your file? Because I just closed that window. I didn't have anything good in there, but I didn't save the file. So in this particular application, it may not be a bad idea to actually have some functionality, but you don't have to do that for yours, for your homework assignments. You don't have to do that. Close on exit. Here we're adding the action listener this on a new file, new save. These are the buttons, obviously, and the action listener comes up from the inherited action listener class. And then on the exit, there's an action listener. There's an action listener on everything. And this is a scrollable pane. That's lo and behold, it is a scrollable pane. So we can create a pane, a JPane. We can create a scrollable pane, but there's nothing to scroll because it's so big to come out with originally. If it was really small, or the text was a lot of text in there, we'd get the scroll bar. So the scrollable pane is going to put in there automatically for you when you size it correctly. So we're going to send it the data. The data is going to be essentially the file that we're going to do. So it's going to be new scrollable pane containing data in terms of the data, which is a string actually. So JPanel pane is going to be equal to new JPanel. So we're creating the panel as well. So we have the scroll pane, we have the panel, and here we're going to add scroll to the pane, and that's the, well, we would actually have scroll on both the text box and the pane, and then we're going to add these guys. So that the pane itself is the bottom section, so if you imagine what that looked like before, we had the big text area up there, and then we had underneath it little bar, and the bar actually word wraps, which is funny. It should be stuck. It shouldn't resize. But the main, we were using a generic kind of flow to it. So set the content pane to pane. So the content pane is pane, and then make it visible. True. This is pretty much as generic as you can get in terms of using the swing components. And this is pretty much setting everything for us, actually. So we're adding a scroll pane to it for the data to scroll it, and then we're making a JPanel pane, and we're putting all the stuff inside of the pane. And so main, as you might imagine, is a fairly small. In fact, I could have put it at the bottom, but it's actually kind of mixed in. This is making a new instance of JPad. JPad pad is equal to new JPad. We could actually have made a constructor that actually took a file name as well. If we did that, we'd automatically populate data, or file chooser automatically select a file from the file chooser when the user opened it up. But this doesn't open up a file. So it's kind of interesting because you could have it open up like using a command line argument, you know, open up JPad with this file. None of these examples are actually doing that. So a new file option, save file option, save file as option, open file option. So the following methods are basically all of the different implementations that are going to occur with the file chooser. So here we have the save F, which is the button, is going to be option pane.show confirmation dialog. And the dialog is going to be on a new file. Do you wish to save the current file before you open up the new file? Which is, you know, let me actually scroll it so I can see it this way. There we go. And this is, you can't see the whole text. Hold on a second. Let me make the screen a little bit smaller. Here, I'll just go like this with it. So the dialog is a common dialog, and it's giving you the yes, no, cancel. And on the confirm, it should open up the save features if you're going to actually save what's in the screen. So it's going to automatically bring up this dialog every time you pick to open something, which is good behavior actually, because you want to make sure you save all the data that's being opened. So if save doesn't equal 2, which means you didn't press option number 2 to save, you pressed option number 1, which was cancel. Then and this is basic common. This is the from the show confirm dialog functionality. You automatically get a built-in object that shows up like a dialog, so you don't have to create a frame and put text in the frame and do all this stuff to it. It's just, you just get it automatically. I'm going to show you the next example does everything manually. This is using all built-in components for everything. So you're going to do some stuff here. If you're going to say data set text to nothing, current file is going to be equal to untitled, because you're going to get rid of whatever was in there before. And whatever happens to that stuff was garbage, gets garbage collected. So if you had a file opened up, you're doing stuff with it, you didn't want to save it, what happens to it? Well, you just set the current file to equal to 0, to equal to untitled, and you pretty much got rid of the text, so you pretty much threw it away. The save file, there's a try and a catch, as you might notice, for exception handling, and it's gonna throw the IO exception, E, which basically said, oh, can't open it, can't save it, can't do something with it. So here's where we're getting the data. The data is right up here, and this is the text area. So the text area data was equal to the new text area, and so the data is basically what's being shown. So we're working with data here to set the text to 0 to get the text. So if we're saving it, we're going to go get text, and it's a file. It's streamed information that's going to be saved. So get text, and then and actually, kind of to note actually something here. This is raw data in terms of the format because it's streamed text. If, for example, we had a Microsoft Word file, and this is where you get the formatted versus raw text. The difference is, you were to open up a Microsoft Word file in your little text editor, you're going to see all the formatting marks. So there's a big difference between formatted and raw, and this is definitely of the raw category, because what you see is what you get in terms of the stream. In fact, it's taking it character by character into a stream, saving it or capturing it that way, and the stream is actually the text that's showing up in the text box. So here's a new interesting one. It's called a file writer out. So it's a writer instance of an object of out is the name of the instance. Of type, data type is an object type file writer. It's going to be equal to a new file writer, current file. Current file is the name of the file. So if we had nothing in there, obviously it would be called untitled. When we use the file dialog file chooser to open up a file, well, we change current file to file selected. So we change which one it is. So we keep track of it, sort of like a pointer. It's a variable called current file that we're using to keep track of all the different files that we have. So we know which one is supposed to be there. So out, which is our file writer object, dot write file data. File data is a string. So we have string file data was equal to data dot get text. So the file I/O, and this is kind of important to know because to understand what exactly is going on. It's stream data, and I believe I covered file I/O a couple weeks back, or a few lectures ago. And we have automatically, with the file writer, we automatically get streamed output, and streamed output is going to be a string that essentially that's put into here. Out.close closes the file, so file writer opens up a file for writing. Write sends the data to it. You can actually send some of the writes to append, to overwrite. The write here is just going to overwrite, actually. It's going to overwrite what's in the file and replace it with this here. And then close the file. And then we're going to have an options pane show dialog message, which is going to show the current file and say has been saved. So the file's saved. Or if there's an error, it's going to show up and say, hey, there's an error, essentially. And then the option pane is going to have an error message type associated with it versus an OK. So the save file, here we have the save file where we're going to do a save as, which is going to put up a temporary file. So we have file2 is going to be equal to new file, laugh out loud.txt, which is essentially a temp file. So we're going to put it all into a temp, and then we're going to save after we pick the name of the file. Because here's the thing, so you're going to save a file, you're going to get the data from the string, and you're going to hold it in this temp file, call it anything you want. And then the user is going to have to select a file name. Once a file name is selected, then you're going to use that as the file name that you're going to save it as. So here we have a show dialog, a file chooser, which is our method, our object file chooser, which we've made an instance variable called fc for. Show dialog this. And then on the file chooser option, we're going to do a try and catch on an if. So if it's an approved option, which means if it's a text file, if you've picked a file out there or you've put a name in there on the dialog to save as this kind of thing. If it's okay, then the file chooser to get selected file, get the name of the file. And when you say get selected file, it just returns the file name essentially for you. And this is all automated. So current file now is going to be equal to, instead of current file up there, file 2 is going to be, current file is going to be equal to file2.getPath. GetPath is going to be the whole absolute path of the particular file that you're saving. And then the writer is going to be equal to new file at writer current file, which is basically the same thing as before. And then write it, close it, so you don't have to worry about running out of memory or corrupting the file. So if you don't close it, you're actually it's still open. So it's good practice to open and close it. Close it when you're done. And then send out a message, a show message dialog that says the current file has been saved. And then if not, send out, if you've caught the IO exception, which is going to occur. Now, if another exception occurs, we're not going to catch it. Like the disk full or something. Well, the disk full would actually give you an IO exception. I don't know. Some other exception that might exist out there isn't going to actually, it's just the IO exception. It would have to be called for this try catch. But that's what we're trying to do with a file. We don't care if we get some out of memory exception or something. So on the open, I'm not going to go through it all in as much detail because now we're getting the point. It's the same concept over again. We're using the file chooser, creating the temp file for file number 2, and we're saying, okay, we know what the current file is. We've dealt with it. Now we're going to open up another file. So open file is going to send out file number 2, which is going to be get selected file. And then the buffer reader is going to read it in. So buffer reader data file is going to be equal to new buffer reader file. And the buffer reader is sort of like, instead of reading in one character at a time and removing it from memory and just going, it's slower. So buffered reading is faster because it reads it all up into a temp space. And then it takes in, here's your string, and delivers it to you all in one shot. It's more efficient. It's like assembly lining it through instead of doing it character or byte by byte. You can actually do a non-buffered reader on this, but then you have to create a loop that's going to actually go through and get all of the information for you. Buffer reader actually also puts an end of file. It automatically inserts an end of file character. So it's kind of like the difference between using a character array and a string in C++, if you're familiar with that concept. So buffer reader is what we want to use on this one. And then a boolean if end of file is equal to false. Excuse me, set end of file to false, and then while it's false, until you get to the end, and then if not, continue going, and then set end of file to true to close it. File data.close. Throw some exceptions. So then we have the event, action event. So this is all of the behavior that's associated with the file chooser, and you can use, yes?
If we read a file using the normal the string reader,
yeah.
So in that case, it does not insert an end of file at the end.
If you delete it?
No. If we are reading it character by character.
Oh yeah, no, it's not going to do that. It's not going to know the end of file.
So how would we check that there are no characters to read?
Without using a buffered reader, you'd have to see if the file size matched. When you don't use a buffer reader, when you just read it in bit by bit or character by character, you say, how many bytes are in this file? And the file says 105. And you read it into while I is equal to 0, I less than 105 or 106, then on the last bit. And then you have to check, did I get all the bytes? Or did I leave some of the bytes?
So the length would include the...
You'd get the length on the file and then read it in for this number of bytes that were, or number of characters, depending upon what reader method you were using and what language. Yeah, it's sort of a manual process. It's kind of like the difference actually between reading strings and character arrays in C++, because character arrays, you have to check the size of that array, so you know how many things are in there, versus the string, you get that null character at the end, so you just read it all in one shot without having to worry about the size. And you can send strings. You can send arrays to functions too, but you can send strings and just get the string and not have to worry about all the extra stuff either. So the action performed is quite simple actually, and this is on the action listener that we put on the buttons in the first part of the code. And this is just nothing more than doing a simple if-else kind of thing, going and say, if it's opened, then open file. If it's closed, close file, or exit, save file as, new file, essentially. And depending upon which button it is. So if the source is equal to this, source is equal to that, how do we know the source? Well, it's the object, which was clicked. So if somebody clicked on this save, the source would be, the action came from the save, which would be the source. So it's the same kind of information, or same kind of format that you would use on any type of program. So just to kind of see the kind of, now that you've seen the functionality of it, to kind of revisit the interface, we see it's, I don't like the size of this window, it's really big, but it has to be that big. And we'll make it like that. But then this text is going to be cut. So untitled now equals to some garbage text that I typed in, and I have to make this big in order to see the garbage text. So if I do a new, it's going to say, do you wish to save the untitled? Because it found something, it wasn't empty. So untitled, actually, when I get the text from this text box element, it doesn't come back with nothing in it, it comes back with something in it. However, I believe this is the way we've got this program designed. This is going to show up regardless, because that's the behavior that was fixed in. So it's really, I don't believe it's actually doing a check to see if the text actually, it just says new. Yeah, it's going to automatically, because we didn't actually do a check. Whether you do that, it's up to you. You can make this a really elaborate program, or you can just assume every time this happens, you have to actually put up this dialog prompt. Some programs are more sophisticated, they'll do a check. Oh, the user didn't type anything. So, and then obviously, the saved is going to put, this is the message dialog. We can change this picture actually if we wanted to as well. We didn't. When we create the dialog, this says message, we actually can give it a title. It says save menu or save functionality, and put a big old saved or something in here. But this is opening up the file chooser to do save. So you can kind of see the file chooser looks the same depending upon whether they're doing an open or a save as kind of thing. Questions on the first example? And exit's just exiting the program. Alright, then moving right along. So if you want to take it up a notch, and we can look at Java 2, Java pad number 2. And as I mentioned before, I'll make these examples available for you. They're not available yet, but I'll put the link in the upload. So when you can, actually, I'll just put it out there in the lecture directory as well. Simple extension of the AWT frame class, as it's mentioned here. Not using Swing, using AWT, Abstract Window Toolkit. Abstract Window Toolkit is platform specific. Swing is multi-platform-ish. So AWT is built on foundation classes for the Mac. So if I run this program as an example, I'm going to get a really true-to-life Mac sort of interface to this. What do I mean by that? Here's what I mean by that. Look at that. Using the AWT, I got a Mac interface up here. It's not in the window. I got my menu showing up here. I can go new. Hello. It's probably somewhere on the screen. No, it isn't. It doesn't work. Open. Yep, there we go. This is the file chooser, but it's the Mac. So the other one before, I probably should have left it up, had a slightly different screen interface to it. It was run from the Swing class, running a J menu. Actually, the J menu was used along with file chooser. Same kind of components are being used in this program, but as you can see, we have a slightly different effect, which makes it, I'm going to have to recompile this for a Windows. Actually, I might get different effect on a Windows machine. In fact, you're going to get the menu up here. You're going to get the menu in the window. You're not going to get the menu because no Windows program has the menu embedded into the OS X menu bar, where the menu bar is supposed to be. If you're not familiar with Macs, and you're a Windows person, you see this automatically. If you're a Mac person, you just take it for granted. You go to Windows, where's the bar? You look for the bar. What happened to the bar up there, man? And then you get used to the bar. And the bar's actually not bad because you click on the item, like this is the Finder, and this is JPEG. And here, you already know where your menu items is. You don't have to go back over here and look for this itsy bitsy little menu item down here. So So here's where the menu items are, and here's a special screen that pops up. It says about, about Java 2. You can put updates in there. And what is this? Services. That's not part of my program. It comes with the OS X. I didn't get services that showed up in my menu last time I created this thing, J panel. So hide, all the Mac related stuff, search, find, help. Help's not part, Anyway, long story short, I'm trying to emphasize the point here. It's done with a slightly different implementation. So let's take a look at it. And everything is overridden, everything's separated out. So what do I mean by that? So here we have AWT. There's no action. There's no buttons on this one. It's using the menu. The menus don't actually do action event. So you don't actually have to do, unless you put buttons on your notepad, which you can do if you want. But you're supposed to put a menu on there. And you'll see the menu. Actually, the next example has the menu. The last example I'm going to show you has your assignments in it. So you'll see what it is after you've seen all the other different choices and ways of doing this, what it is I want you to do. You'll get a good impression of that. But let's see a different way of doing it first. What do we have here? We have Java 2 is the name of it. Extends frame. So over here, JPad, extended J frame. So everything with a J is swing. Everything without the J is AWT, which is kind of the cheat sheet way of remembering that. Frame. Ooh, okay. Properties equal to new properties. Get system properties. So system properties is where that properties is coming from. And then we have file separator is equal to property dot get property file separator. Well, that's going to be your file menu, your file chooser. So it's the same functionality as before, but it's done in a slightly different fashion. In fact, you don't have to put java.awt file dialog here. You could leave that part out because we included it up here. So it's kind of sloppy. What else do we put in here? IO, util, and AWT event is actually in here too. But there's no swing being used in this, is the point. So let's see, what do we got here? Set visible to false. We're going to put, okay, so if we're going to build all the pieces manually, we're going to build them all, have them set, and then set the visibility at the end. Because we're going to get the paint to occur all in one shot. If we don't set the visibility on the window itself initially, and we leave it and it's visible, then as we start populating stuff, it doesn't actually kind of show, unless you have if you have a slow computer, it might look funny at the beginning, and then finally it all populates. If you have a huge program, and you're loading a lot of GUI items, wait till the very last minute to make it visible. Because then everything will be populated onto the screen, and when it goes visible, it's there. Versus, look at that, here's the window, oh, here comes the buttons, here comes the... Yeah, seriously, unless you have a real slow computer, you're not even going to notice the difference, seriously. Set the layout to new grid layout, same as before, actually same components as before. Set the size. Save file dialog, is it going to be equal to a new file dialog? This, save file dialog. Set the mode to the file dialog save. Set the title to save. We're going to have another dialog here for the open dialog. So before we just had one file chooser, and the file chooser managed the component that was on the OS. And the OS component was sort of the once all, the file chooser did the open, the close, everything. So yeah, it's kind of separated. So this is more tedious. Swing actually automates a little bit for you. It's an API written on top of an API. Swing is inherits from AWT. So it's a lot more automation, less work to do. In this particular case, we're creating a save file dialog, an open file dialog. We still got our text area. Our text area is going to be text area, not JText area, obviously. Text area is going to have some bounds to it. We're going to add the text area to the layout, to the grid layout component. We're going to set the title to the Java pad space untitled, because we can change the title every time we open up a file to a new file name. Actually, we can do that in the other program too. This has actually got more functionality to it. You don't have to worry about this, but it has a find and a replace, and all the things you might find actually with a text editor. Searching, finding, replacing, all the different functionality. way above and beyond what you have to do for the assignment. But here we have menu 1. Not a J menu, but a menu 1 is a set title file. And main menu bar. In fact, you can do it this way if you want. You can do your assignment this way if you want as well. You don't have to use swing. You can use AWT for this. I'll give you that option, actually. But you're not going to want to. You're going to use the more automated way of doing it. So we're setting the menu items, and each one of the menu. Look at how many lines of code. How many lines of code you got here? But you have more options in this program, but you have a lot more lines of code actually associated with it. So menu bar, add menu 1, set the label, edit, cut. So there's definitely more menu options. Each one of them is put in here. So the menu item is created and then it's added to the menu and into a particular order. And it's actually added in the order in which it's done here. So it shows up in this order. If you add things in different orders, you're going to find it actually shows up in a different order. If you add 1, 2, 3, and you add 3, 2, 1, it's going to show up the way you added it. Not smart enough to say, well, I shouldn't say that. You can add items in a particular order by specifying the order in the menu. But then you're using a different method. You're not using the standard method. It's just like you can create a constructor to do almost anything, actually. So after we get past all the menus here, we're going to put action listeners. We have the key itself, system key. So the key captures, we also have the same thing as we had as the mnemonics. So the keys were, I think it's going to be still alternate or option with F, G, whatever. So it's a similar thing, a similar functionality, but instead of setting the mnemonic, you actually have to do a different kind of effect for it. So text area, add key listener, and then we have an action that's performed on the keys. And then we have, this is a lot more work. Let's see what else we have here. I'm not going to go through all of it because you're not going to do this. You're going to use swing probably. But in long story short, you have accomplished a lot. And it looks better, looks different. It's a slightly different effect. But if you're going to add the mnemonic, you're going to add the listener on the key for the key combination, and then you're going to have it actually perform an action when it's signed. So here's our constructor. Our constructor is calling this to create a new instance, and it's just basically setting the title. So set the title to title on this, which is our frame, actually set title. And you'll find actually the methods are pretty much the same, except for J menu has a constructor that takes the title all into one, so we can call the constructor with the title. We just do super. So instead we're saying this. If you remember from like week number 1, this basically, is just calling the default constructor. So we're setting the title. We're using the method to do that. This is antiquated. So this is depreciated. So this is an old example. We don't have it. It's still supported, but it's probably display instead of show or something, because the show is kind of, what this is doing is just making it visible. So if I did this actually, I went to bring up the list here, save, select, no, I'm going to say it's probably starts with a D, it's probably display. Oops, I'm pressing the wrong button, which is why I'm getting this. Hold on. Suppose do layout, I bet is probably the equivalent now to it. But I'm just going to leave it alone. So we have file separator, directory name, file name, clipboard. These are temp strings to hold all the information that we're going to get from the file dialog that's going to come in. And so we have our file dialog that we're creating our instances of our objects for the save, for the open, for the text area. And then we also have dialogs for the find and for the replace that's going to occur. And then we have the main menu bar, the menu 1, all of the different menu items that are going to be created as separate menu items here. And then we have a find replacement. So this particular example runs with a couple of support classes, find, dialog, find, replacement, because it has a search and replace find kind of feature to it. Not something that you have to be interested in. I'm actually not going to go over it because you can play around with it and probably understand it quite easily. In terms of the options here with the select all, the paste, the copy, the cut, we're going to have different selections that are all working with the text. So it's all going to get text, set text, save, save it as a string. Our save as is going to essentially show the save file dialog and provide us with the options, and it's going to do a little try and catch on it to make sure that we can do the system IO, the IO exception correctly, and then we can actually save it. And this is actually not using a string buffer, this is actually using bytes to do this in terms of the bytes. So string text area, the bytes is into a byte buffer, slightly different mechanism, using a file output stream for the file. So it's going to take the bytes, write the bytes essentially with file, take the file output stream and write the bytes, which is still buffered, it's still buffered. So, and it does it automatically for us. So yeah, again, showing you another example, just gives you some choices. You don't have to use buffer reader, buffer writer. And usually they come in sets, so if you're going to use a buffer reader, you're going to use buffer writer. You're going to use a file output stream, file input stream. You're going to use kind of the matching set depending upon what you're trying to achieve. And if you're trying to figure out what's the difference between all of them, usually it's the size of the buffer and the methods that are available on it and the underlying implementation. It's kind of like the differences between doing a write and an fwrite and a print or a printf or file, in terms of what C++ the equivalence would be. Okay, then it's going to set the title. Is this on an open? No, this is on a file save. It's going to set the title here as Java plus, put the file name here. Now we have a file, so it's going to change the title of the JFrame. You can do the same thing, of the frame. You can do the same thing with the JFrame, actually. Then we have on the new file action, on the save file action. I'm going to kind of skip through this. On the open file action, it's very similar code. Clean up and close, it's just going to flush the output. Dispose frees the system resources because we're using the AWT. We don't actually get some of it. And I haven't talked about garbage yet, but we have resources that are allocated, and then we have the JVM that cleans it up. And depending upon if it's platform specific, it might not necessarily catch it. So we have mechanisms in there to actually just force it. Essentially, make sure it happens. A close is a necessity. You should always close a file because otherwise you might end up with some corrupted data. Because the closing of the file, until you close it, it doesn't get garbage collected. You guys know what garbage collection is? Reference counting? This uses so Java uses a combo of a reference counter, and I can't remember what the other one is. Technique is algorithms essentially to figure out what's being used and what's not being used. What's meant by automatic garbage collection, and that's the next lecture actually that's coming up either today or tomorrow or Wednesday, is that as you allocate resources, and the only thing you're allocating really is memory. When you open up a file and you load it in, using either one of these two techniques, it does the same thing. Takes creates buffered memory for you, or creates memory for you, stores the file. So you only go to that I/O device once, read it in, and then you have that memory. So the allocation of that memory allocates. Well, in Java, we don't have a new and a delete. We don't actually manually delete stuff. In this case, we actually are manually deleting it. We're disposing it. But normally, we would just leave it alone because once it's no longer being referenced, the Java automatic garbage collector kind of sweeps through. Sweeping is the word I needed. Sweeps through, looks at references to memory, reference counting, and says, it doesn't use a counter, it uses references, however, that says, hey, this program's using that one, this piece of memory is being referenced, and it comes by and says, oh, hello world, or something, what is this? Nobody's using it. Let's take it down. And it frees up resources. It usually runs when it's running low. So until it actually, and it's a mystery to me when it actually does run, but until you start running low on resources, the garbage collection is going to run at different paces. Because if you had the thing running constantly, and this is the problem with garbage collection in general, you have something running, a process running in the background constantly, looking for memory to sweep up. That's a waste, because while that's happening, your program's not running, something else is running. So the trick is to make the garbage collector only turn on when it needs to be turned on. So people in C++ worlds, you can get a garbage collector class, make an instance of it, and have it sweep while your program's running. And just at idle times, it can actually work. Actually, it's quite effective. That's because, we forgot to do a delete. So you allocate, but you don't want to have to worry about deallocating. So you can run with garbage collection. Anyway, long story short, that's what the dispose is about. It automatically enforces garbage collection, frees the system resources once you've cleaned up and closed the file. Because technically, and you can run the dispose on the using swing as well, but you don't really have to. Because technically, once you've closed the file, for the program's sake, it's closed. The memory is still allocated. The memory is still out there. If you're writing a huge database application that's loading a bunch of data and creating creating tables and stuff out of it, and you're running queries on it, you've got a bunch of temp results being stored, you probably want to flush that out. You probably want to dispose of some of that stuff. Otherwise, you're going to run out of memory. Or you're going to force a garbage collector to run constantly or something. So it's a design consideration. The find functionality, automatically find and replace, find again, text area, there's a key pressed in the text area, pick up the key press, and F3 on the keyboard also. We'll see that. I'll run some of the keys in a few minutes and we'll see what happens. This one actually uses function keys as well, I believe. Here's our class for our action listener that's taking the Java AWT event action listener. So we could have put action listener, we could have implemented action listener from our class, but we didn't do it that way. Instead, there's a subclass down here that's doing it. And the subclass that's doing it are the actions that are going to be performed on each one of the menu options. So the about action, the exit action, and each one of these guys, most of them have own separate dialogues. As an example, actually let me get through this. I'll show you the about and some of the other screens. And so this is going to be for each one of the actions that are being performed. Kind of tedious to go through, but you have to actually select the actions for all of those different options that have possible actions that might be performed. And then we have instances of objects as an example, the about dialog, that little screen that came up. And the little screen that came up is also from the AWT. It's not a dialog, it's the about dialog that extends dialog, which is the generic AWT dialog, that's going to bring up, from the parent, it's going to bring up a modal form. So we can actually tell it whether it's modal or not, which means is it going to be like a pop-up screen, or is it going to have a frame around it with options and a close and an open and all that stuff that's associated with it. Here we want modal, which means it's just going to be a control-less, little lightweight dialog that's going to show up. Setting the layout, setting the size, setting the text. This is a simple editor written in Java. Putting a label button on there. And then the button itself is going to have a OK. We're going to add OK to the layout. And OK is going to have a label that says OK on it. And set the title to about. And put an action listener on there. And the action listener, again, is sort of a manual kind of way of doing it. And then we have the frame parent with the string title and the modal mode that we're going to actually send it to create it, because it is a frame. It's just a different type of frame. These are all frames, by the way, that are being actually created, but it's being created inside of the parent frame. And actually, I'll show you that in a few minutes. Because the activity is a little different. If one's a subframe on another frame, you have to get rid of it. Otherwise, you can't access the original frame because it's of the hierarchy. So when you close, it goes back to the calling frame. So here, this is just nothing more than setting a label, setting a button. And you notice you got no J's, so these are AWT components. And then setting the listener on the button, because there's an OK button. So before, when we set the dialog, simple dialog from the other branch, we had an automatic 1 or 2. Did they say OK or cancel on the save? And then we can take 1, this, 2, that. Here we actually have to put action listener, create the buttons on the dialog, put action listeners on the dialog, and then figure out what happens when they click the dialog, what happens when they click those buttons. So it's a little bit more manual. So all of the actions, nothing's going to happen, nothing's performed, but if there was something performed, you can put it on the action performed on the OK button. So, which is if the object is equal to, and there's only one object on there, is the OK button. So you can add a bunch of buttons to that. You know, if you really wanted to create custom dialog, that would be the way to go. And then it's running at this dispose to clean it up as well. So I'm not going to bore you with the rest of it because you can download the example and take a look at it. But there's also one for the find and find replace. Actually, find replace engine is the functionality behind the find. And so just to reiterate some information here, if I run this application, just to refresh your memory, and I take a look here at the about. This is the about. Oh, it does work. Okay, but it's actually different than I expected. Yeah, no, it doesn't have the border around it. It's a single border, but the look of it's very similar. And no, there's no control. You can actually put control on it, so this retains focus. So if this is open, because otherwise this here could actually be closed. And oh, it went away. Okay, but technically you could essentially close the main window and leave sub windows open in that case. So it depends on how you want to do your design. You can add focus to it so it doesn't go away. You can do this on Windows too, actually. So, questions on that one? We have another one. Going back to swing. This is going to use a combination of swing and AWT. Same as before, but now we know we have swing because we have JFrame. Let me run Notepad so you can kind of see what Notepad's doing. Notepad is just like the AWT example, except for the one that says Notepad on it is doing it with swing but accomplishing the same task. So instead of putting the menu in here, it's putting it up here. So we have file, open, save, close. But it's not using AWT, it's using swing. So you're going to see the same functionality as before. This is a test, except this is bold. And the file, open, and this is the file chooser. Remember from swing, so it looks a little different. It looked a little different than the open dialog and the save dialog and the close dialog. I don't know if I showed that to you, but if you wanted to just run them, you'll see the differences. This is more generic, more platform independent, per se. You'll get a Windows-looking one on a Windows system, though. But you can kind of see the same menu bar that's up here. If you run this on a Windows machine, it's going to show up in here. It's not going to show up here. So you can use this technique on this example, and you're looking at this going, oh. But I'm going to get it. The last example does it and puts it in like you're going to see it on Windows, but it does it on my Mac. So that's what the difference is between all. You're going to be Notepad overload by the time you get done with these examples. It's Notepad on steroids. All right, so plenty of stuff to choose from, just like the data structures examples. Plenty of stuff to pick and choose from to write your. And you may use any of the source code to create your homework assignment. All right, now I can kind of whiz through this because a lot of commonalities here. What do we got? We're going to have menu items that are created for the, and this one is full of, this one is also full of comments too. So it extends JFrame, implements action listener. We're going to have a text area, obviously. We're going to have a menu bar that's going to be the main menu bar, for which we're going to have the submenus. And the submenus is going to be a menu file. It's going to be a new menu. And then we're going to have menu items that are going to show up on the menu. So we have menu bar, menu items. And we put the menu items in the menu. We put the menu in the menu bar. Open, close. Here's our main constructor. Initialize the window to 500 by 300. It's kind of a smaller window this time. Set the title of the window. This time we didn't run actually the constructor. We didn't run super on this. We did it manually instead. And you notice that we're using this. We can actually take this out of here and it works just fine because we don't actually, this is only one class that runs Notepad. We don't have multiple classes in here, multiple objects. So the text area, this is where we're getting the bold, Century Gothic. Interesting. What if the user doesn't have this font? It depends on how you designed the program. You could select a font that's kind of universal, or you can select one that's, and then set a default. So, or set an option, you know, where, and what it's going to end up happening automatically if you use swing, it'll show it in whatever it thinks more. It'll just show it in whatever font's available, whatever the default font is set for the desktop for whatever Windows, Mac environment. Using AW2, it might actually be empty. Because, or you might get an error message, and it's going to be a strange error message. It's not going to be associated with the font. So it depends on the obscure title of font that you actually pick. You can actually go through, query it, do some checking on it, see if that font exists. If you're going to write like a sophisticated app, you can actually see if it exists, if you really want to use that font. And if it doesn't exist, add the font. Because you can actually take and use Java to add fonts to the operating system. Or supply the font, which is not necessarily a good option. So here's a setting of default fonts for the text area. This is why we didn't have to worry about the size of the text area, because this is going to actually set it for us. We have the border layout that we're going to use on here, so it makes it fit in automatically in the border. Get the content pane, add the text area to the content pane, add your menu bar into the GUI. So this one, actually the menus themselves are going to be, the submenu items are going to be configured later. That's the other interesting thing about this example. It puts everything together before there's any menu items. Adds the bar to the menu bar, adds the menu bar to the component, sets everything up before we actually have the inner components. So you can do it this way. It might make it a little bit more complicated to follow. This is heavily documented, so it's kind of showing you everything. Or you can just do it sort of in a sequential fashion, and then you can kind of makes it all seem more consistent, or seems like you're not going to forget anything. So here's the menu bar. So first off, the menu bar itself, pretty simple. Set the file. So the file is going to be set to the label file, which is just a generic, instead of untitled. And so now some repetitive stuff, as the comment says. We have the file open, which is going to be labeled open. Add the action listener to it. And you see it's kind of the same as before, but now we have menu shortcuts that we can add here for certain. Instead of using mnemonic, instead of running a mnemonic method to set the mnemonic for like a number, now we're going to use shortcuts. So you can do F. I didn't show you the F function on the last one, but you can do like F5 or something, or different shortcuts to manipulate the interface instead of just pressing down the options button along with the first character of the menu item. So you can set it differently. Let's see, add it to the file menu, the save functionality. And this one I'm not going to go through that much because here's a Control F4 shortcut to close the window. Actually, that was added. This example is pretty heavily documented. So, action performed, same as before. Check to see if the user clicked on something, one of the menu items. And then here's a dispose all the resources and close the application. We're running a dispose again. Let's see. If it's open, do this. This is using the scanner class with the file reader, which is another way of scanning for input. So some of you actually may have experimented with it. Instead of using system.out or system.in, you can actually create instances of scanner. Scanner will essentially do the same thing. It does I/O actually. You can use scanner to get input from the keyboard, input from a file, so you can scan. And in this particular case, we're creating a new scanner, and this is going to be a new file reader. So we're opening up the selected file into a file reader, we're scanning it, and we're going to essentially put it into the scan object, which is actually very similar to the system in object. But we don't necessarily use system in and system out for anything. We just essentially take it and copy it to something or do something with it. This can actually hold on to it. It has more buffered memory associated with it. Scan has next. It's a data structure where not only does it have more buffered memory, but it has more functionality associated with it as well. So if you remember the data structures that we went over with collections, we can say, which is what scanner actually falls into. We can say has next, has previous, is it empty, is it full? Kind of checks on the items themselves. And we can easily do it is empty, because this particular program actually looks, before it tries to open a file, this makes sure that the text area is empty, which you can do because you're using the scanner class. Alright, so here's the save functionality using the file chooser, and then the main is down at the bottom of the program. It's actually created here. Notepad app is equal to new notepad, and then app.setVisible is equal to true. So it's going to set the notepad instance to set visible. So everything is created again before. It is more common actually to see the main method, if you're going to do it this way, put it at the bottom. It's more common actually because then you can find it. Some of the other examples had it nested in between. So, alright, and I believe I ran Notepad. I just want to show you something with the keys actually. And then we'll get on to our last example. Works with this. So here we have different key sets. We have the command F4. Where's F4 on here? Here we go. Function 4. Well, actually, I have to go function key and F. I actually have to hit 3 keys for that to get into the search, to initiate the search. But I didn't have anything selected, so as you can possibly imagine, you've got actually. That's the Notepad too. I'm like, where's my, I had that one running, I guess. I wanted to run Notepad, not JavaPad. So I believe I closed it though with that key combination I just did. Play with it, open it up, you'll see you'll have different selections. It's not always the alternate phi. It's function, command, this, it's, you know, it's a combination of different keys that are actually creating the functionality for you. Okay, I did something else in this project because I was thinking about it and I'm like, did I explain packages? Did I explain scope and stuff like that? So I created this project called JP assignment number 4, and I put a default package in here. Actually, I didn't put it. I just made files without packages. And there's no package in this file. On the top, there's no package information up here. And then I said, well, let's see what happens if we do have a package. And you can see it creates a new package subdirectory in here. And I have this last example I put into a separate package to show you can have multiple packages in the same project. Why do you want to do that? Well, you probably separate. In this particular case, I probably could have created 2 more packages and separated this stuff out. That way, if I wanted this notepad, I can call it all the same thing. So I can have in here, I can have notepad.java. Here it is, notepad.java. I didn't actually call it notepad. Well, it's capitalized over here. It's lowercase over here. I can have the same names. I can have like 5 different programs or whatever I want. You know, same file name, same different package. It's like putting it into a different directory. It might help you organize your project a little bit, depending upon what you're doing. If you have a huge application, let's say you're building Microsoft Word, you're going to have the main menu kind of interface. You know, you might have to keep that in a different package. You're going to have sub-package maybe for some of the features for graphics maybe, or for inserting or deleting and stuff. And if you separate everything out, it's a lot better than looking at one package with thousands of files in it. You're not creating anything that big for this class. But, you know, in the real world, packages help you organize your stuff. And then you can set the scope for the package. So you can see things inside and outside of the package, make it accessible to the public or make it private. So you can kind of play around with that. So here I have an about. And the about's in here. And actually, let me run this one so you can see. This is using Swing and AW2, and it's definitely a little bit more advanced, but it's kind of broken out like a real program. So there's a main, there's a font chooser in here. Well, I didn't do the file chooser. Well, it's built off of a file chooser. I did not do the foreground and the background text. This one's going to choose fonts instead. You're doing colors on the foreground and the background colors. Your file menu is going to be given for you automatically in all of these different examples. So that one's a no-brainer. If I run this guy, and I'm going to run main actually, if I right mouse click here, new run as a Java application. Let's take a look, see what this one looks like. I've got the window and I've got this up here, but I just have the basic, and this is going to happen every time I create an app on the. I'm not using it though. There's nothing really up here. So the functionality is right here, and I can see I have a file menu. and I've got the keys set for Control N or Control O, but they're actually on the label instead of showing up automatically. So they're not using mnemonics because I'm pressing the keyboard right now. Nothing's changing. It's using a slightly different way. If you don't want it, you don't actually have to put mnemonics, or you don't have to put key shortcuts here either. This one has an edit, has a lot more functionality than what you're going to use. It has a format for fonts, converting to upper and lower case to word wrapping. Has an F1. So if I in the application here, if I press F1, function F1 on my keyboard, there we go. I get the About window that popped up because it says press F1 up here. So that's where that About window is coming from. It's basically a combination of all the other examples with the menu right here. So it's more representative of the assignment itself, actually, except for it doesn't do the foreground background colors for you. And you can't just take this one and turn it in because it's got a lot more functionality than you need. Unless you strip it out, and you could do that. You could take that approach too. Some people like to backward engineer if you want. So there's no excuses, essentially. Well, there's no excuses with any of the assignments. I know, it sounds easier than it really is. This is the About. Let's work with Notepad first. Now I can, Now I can kind of show you this really easily. These are all of the imports. Lots of stuff in here. Because nothing is actually prefaced inside of the code. Everything is imported instead. So this is more, nicer in terms of design. All your imports are right here. So let me close these imports. It takes up. And the package is Notepad because I've put it into a different sub-package of this project. So I got class Notepad. Notepad actually should be capitalized for, for purposes of. Originally, when I added it in, it was in a separate. It was in the same package, which is why it ended up lowercase. But the names of your objects should be uppercase. Implements extends JFrame, implements action listener. Okay, yeah, no brainer. Container C, panel this, text area that. This is more standard. If you want a best practices application, this is it. Because you've got all your imports, nothing is prefaced inside, and you've got all of your variable declarations right here. You got like a page of them right here. So throughout the code, it's just going to use all these objects. So if the object changes, you can find it. If you want to change it, you can. What was that menu item file open called? Or it's like the old C days when you put all of your variables up front with their object references in this particular case. Undo manager. What is the undo manager? Okay, so this program here has got find and undo and a bunch of other built-in functionality from Swing. So a bunch of extra objects that are created because there's a lot more functionality in this. So making an instance of the object for the undo manager. Oh, okay, so you can automatically use the built-in functionality. Find finder, file chooser, FC, about, string, path, and content. So we have the path and the content. So here's our constructor, and our constructor is going to call super because we're working with JFrame, and it's going to be Untitled Notepad is going to be the title that we're going to put on the screen. Then we're going to do a try and a catch. And the try, and this is still in here. Actually, I should have taken it out. We don't really need it in there. Is using on the UI manager set look and feel, which is yet another separate, different. You don't have to do this either. Actually, the first example that I gave you didn't have any of this stuff in here. This is everything. So it's going to make a new instance of the object for the, and we're going to actually give it a UI manager component. And the UI manager is going to control the look and feel. We're making a new instance of this particular object. Actually, we're not even making an instance of it, and we're not using it as a reference. We're just calling the method to apply it. So it's going to apply the get system look and feel class name to the set look and feel, and it basically goes through and aligns for the layout, make sure that everything is properly adjusted, not overlapping, stuff like that. Again, optional. We haven't seen that in any of the other examples that we've seen so far. Do some exception handling and print the trace stack, which tells us there's a problem with the interface. Because we have so many components in here, it's not a bad idea to manage it with the UI manager, which is the optional way of doing it. You can self-manage it as well. but you can't do any error checking on it. It won't go through and see if the regions are visible. And what exactly the UI manager actually manages, there's an entire list of documentation online you can look up to see which components are being managed by that. So we had the new text areas before. We're setting the font baron. That's a pretty standard font, actually. Setting the scroll bars on the pane, creating the new menu bar. The new menu bar, here's all of the menus that are going to be associated with the menu bar. And we've already created the reference of the object up here, so we don't have to do it down here. So we have menu bar is going to be new menu bar. We've already created that menu bar reference. And then we have file, and here's all the things associated with file. Then we have edit, and here's all the things associated with edit. That's what I say, this is very well organized. Format, everything associated with the format menu. And everything is associated with it, I mean, by association is the name of the item, the action listener on the item, and then you know, the key, in this particular case, the keys, the keystroke for, and this is using a set accelerator, which is a, what's the word for it? Synonymous with set mnemonic, but it's used in a slightly different fashion. It actually captures the key action, captures the key presses versus the mnemonic. That sets it for you automatically, tells you what it's going to be. Okay, so they have the convert menu, the format word wrap, the help menu. The help menu is doing nothing more than showing up the help dialog. So it's creating a new J menu about, loading up that help, adding a listener on it, adding it to the menu. Let's see, setting the default close operation on the window to hide on close. So actually, that's an interesting. Let me see something real quick. Actually, I don't think that's actually working. No, it's closing. It's not hiding. So, yeah. Not perfectly running. That's not a hide on close. No, wait a minute though. It's on the Finder. It's on the Finder window. It's not on the main window. If you load this up and you look at the Finder, go into the Find options. When you close that, it gets minimized. It doesn't actually get closed. It just gets hidden. Because you're supposed to essentially be looking at whatever it's supposed to be finding. And you have that dialog that's kind of behind the scenes, and it's still there, but it's not being used. Then we have our actions performed, or different events that are going to happen on each one of the items that are selected. And then we have the functionality for all of the different file choosers, as we saw in the original example, the file open, the file close. And this code you might find interesting. We still have the temp, the concept of the, keep a temp name, keep a temp file, keep a temp string, read it in, copy this one to copy it to that one, or take this and save it as that one, kind of concept. Same functionality, pretty much the same functionality, the same implementation as the first example I showed you. The file open, the file close, file save as, and then we have the, does myfile.exist. There's a little bit, I shouldn't say the same, there's a higher level of sophistication in terms of the features and the options. You're certainly not going to implement this example. I don't think so. You're going to probably take one of the Java pads probably and convert it, maybe the first one if you're going to do it. So. But this one is going to be basically showing you all the subclasses as well as an example of that, and I haven't shown you that yet. Another interesting one to kind of observe would be, and I guess we're going to do all examples today because I'm looking at the clock. I'll save garbage collection for Wednesday. We can garbage collect on Wednesday. This particular file that I just opened is called Font Chooser. It's going to implement Action Listener, and it's also going to implement List Selection Listener, which is going to happen when we open up a new JFrame Font Chooser, which is going to be the JFrame window that's going to allow us, and I'll open up this window so you can sort of see what what it's actually going to do. Now we have a Notepad instant swamp, excuse me, sample, which is going to be the Notepad sample to show you the font that you're going to select. And what the listener does is on an item selected, it's going to change. In fact, let me just show it to you so you sort of see what I'm talking about. So let me just run it. Probably should have just left it up there. This is a test. So we're going to highlight the font, we can change it, we can go font. We have this little screen down here that is a notepad. And the notepad down here is what's being changed on the clicked listener. So if I go here 16, 18, the main window is not being touched. But the bottom window, in fact I didn't have to select that I guess. But so this is where that sample preview is actually a notepad. So this should hopefully look like what it does in here, but all of the information is excluded. So just a generic notepad window. So you can kind of see how you can nest items, I guess is what I'm trying to say. And then once you select it, this particular text was applied. So it took this notepad.text and copied it to this one. Well, the font, changed the font thing. And if you look at the code, you can kind of see what it does. You don't have to do this. Changing the font color and changing the font, the screen background is simple compared to this font selection. Fonts are a little bit, choosing a new font and applying it is a little bit more tricky, but not impossible. You're just setting you can set the text box to the font. Use this font. So remember that other example before, if you want to do this, actually, you're going to do this with the color. So if the user change the color, the foreground color to red, you're going to take the text box and you're going to set the text color to red. Everything that appears, it's not going to change the file. The file is a text file. So that's the other thing we usually have one or two students ask me a question about this. Like, well, when you change the background to red and the foreground to white, and I saved it and I brought it back up, it's still going to be black on white. It's a text file. You're not saving any of that. So this is where, if you want to build a word processor, then you would save that information. And then that's why we get, formatted text files and not text files, because in a Microsoft Word document it says that there's a tab here and that the text is in this font and then that text is in that font. And we have all this special formatting that's saved with the file. This isn't going to do it for you. It's just going to change the display. And the same thing in this particular example, the same thing with the font. I'm not going to save the font information for you either. So if you want to do that, you got to write a word processor, not a text editor. Alright, so what do we have here? Just the same old stuff. We're creating JLabels, and we have a bunch of labels in here, and JLists. There's going to be a bunch of lists. In fact, that was the list that showed up in the list box. So the interesting thing is this component that I just showed you was created using these items. So that was a list. It wasn't like a built-in file chooser component. This was actually built by using JFrame and by using JLabel and JList to populate the different sections, and then also creating a note text area as well. Font name, keeping track of the name, the size, because we changed the size on it too. And so we're sending the reference for the notepad to it, so we know which notepad, which window is going to be applied to the change. We're essentially selecting the change, adding the change to the text box. So this is nothing more than querying the system to find the list of available fonts. So get available fonts family names is a built-in method that you're going to be able to use. And you're running this on graphic environment, get local graphic environment, which is a built-in method again that's being set on the that's being set on graphic environment. It's telling us everything about the graphic environment. So you can use this to get a list of fonts, list of color. Well, colors are pretty generic. List of features. Is this installed? Is that installed? You can also use the get environment to know, are we running on a Windows machine or a Mac machine? Get the OS information, how much memory is available, how big the hard drive is, how many hard drives are there, do they have this, do they have that? So get environment is pretty, and this the environment is subclassed, so graphic environment is just the graphical components of it, the GUI end of it. So that's where the fonts are going to play into. We can actually get environment, use environment actually to get processor system information from different subclasses of environments. All right, I think it's system environment, I believe, is the other one for system information. But you know, you're never going to remember all this stuff. You're going to look it up. So, all right, so we have the action performed, the value change, then we're going to set up. In fact, this one is smart enough to know that if you've made a change, you want to save it, versus just blindly clicking up a, would you like to save before you open? That kind of dialogue. So it's a little bit more sophisticated. If you're writing something that was, you're going to basically use as a text editor, it's not a bad option. In fact, I have had a lot of students in the past use their text editors. In fact, it's a text editor, especially if you don't like Text Wrangler, don't like Notepad or some of the other options. You can create your own text editor and run it. So it's a little bit easier to do it, I think, on a Mac computer actually, because Notepad's pretty good for Windows. So. All right, well, I'm looking at the time at 6:45. I've got a recruiter slash, actually here, let me end the video here before I've saved a little bit of room here. I told her I would end at 6:30. Hold that thought for 1 second. I'll explain as soon as I end the video. What I'm going to do with this is clean it up a little bit and put it on bhacker.com. So you have all these examples. I highly recommend